Okay.
Good afternoon, Dr. Wan, and this is the Group 7 lab discussion. And we're discussing now about the lab discussion part. So yeah, can get.
So first, I think we are going to explain what is Haldane effect and Bohr's effect, just like what doctor asked us to discuss and do research about Haldane effect and Bohr's effect in the video. I'm sorry, excuse my sound. So may I start first? Because we are all explaining one by one. However, the point will be same and we might repeat, but I just want us to know that we are clear and we understand what is Bohr and Haldane effect, just like what doctors want us to understand. Okay, so I start first with my explanation. Haldane effect is like describing how oxygen concentration can determine hemoglobin's affinity for carbon dioxide. For the easiest example and the most common example for this, the exchange of gas in our. So that's the most common example because there's an exchange between oxygen and carbon dioxide there. So high oxygen concentration will replace and diffuse into the blood, and carbon dioxide will just go replace carbon dioxide in the hemoglobin. So proceed to Bohr's effect. So the most common example for Bohr's effect is during we exercise for our active muscle when we exercise doing exercise. Yeah, it's because Bohr's effect describe how carbon dioxide and hydrogen ion affect the affinities of hemoglobin for oxygen concentration. So the higher the concentration of carbon dioxide and hydrogen ion, the lower the affinity of oxygen. It's because carbon dioxide has lower pH. Yeah. So that's my explanation. Do you guys understand? Is it understandable?
Yes.
Yeah.
Okay.
It's a good example.
Yeah. It's
Yeah.
the most common example that I can give.
Yeah.
Okay, so next.
I think I go for next lah.
Okay.
Okay. So same lah. I will share the image here on my screen. Okay. So for the Bohr's effect and Haldane effect, like normally we know when diffusion of gases occurs, it occurs between lung and tissue, and then there are several ways for us to diffuse our gases. So from lungs to tissue, we diffuse oxygen through oxyhemoglobin, while tissue to lungs, when we diffuse carbon dioxide, we're using carbonyl hemoglobin, if I'm not mistaken lah. So basically, Bohr's effect is we observe the concentration of oxygen, while for Haldane effect, we observe the concentration of carbon dioxide. So we came up with the graph like this. So as I mentioned just now, the Bohr effect is we emphasize on oxygen content. So the graph here will be oxygen, partial pressure of oxygen, while Haldane effect, the graph here will be carbon dioxide content, while here be partial pressure of carbon dioxide content. So basically, if normally when Bohr effect doesn't occur, the line that we construct will be here. The green one. Is it the green one? Oh, the blue one. So when Bohr effect increase, we will discover that the oxygen delivery from the Bohr effect is actually greater than the normal condition. Is it clear? Like if Bohr effect occurs on our body, we will realize that the oxygen delivery will greater than the Bohr effect does not occur. Okay, understand? So same as the Haldane effect, when Haldane effect occur, the carbon dioxide delivery is actually greater than normally when we just diffuse the carbon dioxide. Yeah, so that's the explanation for me. How should I end this? Okay.
Okay.
How about
Next.
yeah?
I can go next. Okay, so for Haldane's effect, it basically describes the oxygen concentrations which affect the affinity for carbon dioxide. And for example, when the concentration of oxygen is high in the lungs, it will replace, in the blood, it will replace with CO2. So basically, oxygen is affecting the affinity of hemoglobin for CO2 and hydrogen ions. For Bohr effect, it's how carbon dioxide and hydrogen ions affect the affinity of hemoglobin for oxygen. So which basically it's the reverse of Haldane's effect. So yeah, that's all.
Okay, for me, the Bohr effect is when the carbon dioxide or hydrogen ion affecting the affinity of hemoglobin for oxygen. When we inhale, the lungs will transfer the dissolved oxygen and oxyhemoglobin to tissue. So when the oxygen arrive at any part of tissue, especially thigh, the pressure of oxygen is low. So after it arrives at lungs, the oxygen is high. So the Bohr effect will maximize the oxygen gas delivery. So more oxygen will be delivered to the either thigh and lungs. So for the Haldane effect, the concentration of oxygen affecting the affinity of hemoglobin for carbon dioxide, where it will maximize the delivery of carbon dioxide in either lungs and thigh. So it's basically the vice versa of the Bohr effect. So that's all.
Okay. Thank you, Hafi. It's quite clear.
Yeah, it's so complete.
Yeah, it's complete explanation. So for the next topic we are going to discuss is the differences between buffer and acid or base or solution. Is it?
Yeah.
So maybe we can start with Sondos first.
Okay, so for acid has low pH, and base has high pH. But for salt solution, it's almost like neutral. And for buffer, it can minimize the pH change when we add on weak acid or weak alkaline. So this is the difference.
Agree. So next.
Okay. So what's the difference between buffer, acid, and base? Just like what Santos say. Acid have pH value of lower than 7, and alkaline or base have pH value above than 7. So if it's a strong acid or alkaline, if strong acid, the pH will be much lower, just like 1 or 2. If it's strong base, it will be 13 or 14 like that. But if it's weak, it will still be less than pH 7 if weak acid. The value was not that extreme. Maybe 6, 5, it's also considered as weak acid. For buffer, it's actually a mixture of salt, like acid and base, to it's like actually a salt solution, but it can minimize the pH value, the change in pH value of each acid and base. So yeah, that's my explanation
Okay.
of the difference. Yeah.
So I think I go next. Okay. Yeah. Okay. So for me, acid is a chemical that can donate a proton like donate hydrogen ion, while the base is the chemical that can accept hydroxide ion, which is OH negative lah. So the difference for me between acid, base and buffer is buffer is made up of weak acid and conjugate base, or weak alkali with conjugate acid. While acid and base is just simply like acid and alkali. It can be a strong acid, a weak acid, or a strong alkali, weak alkali, but they didn't mix up. So for buffer, there's a function like it can minimize or resist the pH change when some weak acid or some weak alkali is added to it. So to maintain the pH change in our body, that's the function of buffer. Yeah. So that's my understanding about about buffer and acid or base.
So for me, the acid is substance that contain hydrogen ion, whether it is high or low concentration of hydrogen ion, which can be indicated using the pH value, which is lesser than 7. Or, and for the base, there is substance that contain hydroxide ion, whether it is high or low concentration, and that can indicate by using the pH scalar that value is more than 7. So for the buffer, yeah, actually it is a combination of two, acid and base, whether it is weak acid plus conjugate base or weak base plus conjugate acid. So the function is to minimize the exchange of the pH, or to maintain the pH of the solution. And for the salt is actually is combination of any substance, and mostly it is neutral. pH is 7. So that's all.
Agree.
So to have an add-on, actually buffer have two types, which is acidic buffer and base buffer. Do you guys know this? Yeah. Okay. So any questions from the video that we missed out? So here I have one. It says what buffer do, like how buffer functions and how does it works. So Hafi, do you want to start first, or we start first? Or Sandos, do you want to start first?
Okay. So buffer helps to maintain the pH of the blood and also other fluids in the body within a narrow range. So that's how buffer functions.
Yeah, okay.
Yeah, yes, for the addition, if acid were added to the buffer, so the buffer will remove the most of the new hydrogen ion. Otherwise, the pH will drop markedly because the acid were added. So the pH will remove the excessive of hydrogen ion. So if alkali were added to the buffer, most of the hydroxide ion will will be removed by the buffer. So it will maintain the pH.
Yes. Yeah, true. Any add-ons?
Okay, so I think for me, like human body is like 70% made out of water. Then water actually is an example of buffer, as we know like water is made out of hydrogen ion and hydroxide ion. So it also helps to maintain the pH value in our body. So when we add maybe some weak acid or weak alkali, water actually can neutralize the acidity or acidity of the acid to help us maintain the pH value of our body lah. That's a
Okay.
example I found. Yeah.
So, in my point of view, no, I'm just going to add on. Yes, buffer. How the buffer do is just minimize the change of pH. To minimize the change of pH when acid or base is added to the buffer. But I just want to say that because buffer, it's only small amount of acid or base can be added. If it's a large amount, the buffer pH will eventually change. It will not. It is just minimizing, but the pH will still drop or rise if we add too many on it. Yeah, so that's to conclude. The buffer is just to maintain the pH value and to minimize the change of pH value. So any questions like in the video that we missed out?
I
Before
think
we
that's
proceed, that's all. Oh, okay. I add on one more because doctor did ask what does the pH value for the part 1 indicates. I'm just going to say this, that the pH value shows the concentration of hydrogen ions. So if the pH value is lower, means it has higher hydrogen ion. Okay, yeah. Okay, that's all. So we can proceed with our discussion, right? The part 1, part 2, and part 3 discussion.
Yeah.
I think we have done the videos question, right? Like what doctor asked us to discuss. Am I
think
correct?
that
yes.
yeah.
Yeah, that's all. Okay, so let's proceed with the part 1 PDF question. So actually for the part 1 PDF question 1 and question 2 is almost the same. So when we can answer question 1, we basically can just answer question 2 is because it's just the opposite. Because one it's acid added and the other one is base added, so we can just discuss one of it. Yeah.
So maybe we can state the question first before we answer it.
Yeah, sure.
Yeah. Okay. So I think I read it lah. Then you guys answer. Okay. Okay. So
Okay.
the question is, hydrochloric acid was added 1 drop at a time to a buffer solution and to deionized water. Compare the change in pH observed with each drop of acid added to the buffer and to the deionized water. Did the buffer minimize change in pH with each addition compared to water? If it did, explain in general terms how the buffer was able to do it. Yeah, so
the answer was definitely a yes, that it minimized changes, since before this we already discussed it together that buffer did minimize pH because it's one of the function. And in this case, it's the buffer is acted as a base buffer solution because the hydrochloric acid is added. Am I wrong?
No.
Okay. Okay. So when base solution is when acid is added in a small amount, the hydroxide ion will dissociate with the with the buffer and neutralize the solution. So this can minimize the change of pH in buffer. Yeah, that's why the buffer still can have the same amount of pH. Yeah.
yeah, I agree with Audrey, because the concentration of hydrochloric acid is actually quite low, means it's a weak acid, and it added with a small amount, I think, not very much. So the buffer still works lah for me.
I'm sorry, Kelly, but hydrochloric acid is actually a strong acid.
But it's 0.1 molarity. So in
Yeah,
this
it's diluted. Yeah.
in this case, the hydrochloric acid is weak acid. Okay. How about
So
deionized water? Sondos?
yeah, just like you both said, because when the acid drops in the when the acid drops in, it undergoes partial dissociation.
And for the ionized water, if the acid were added, the pH will drop because it is hydrochloric acid. Because in the water there is no ion, so the hydrogen ion in the acid will take over the water. So the pH will not maintain and it will drop.
Yeah.
Okay, so yes, for we complete our question 1, because just now I did left out the deionized water, so yeah, we did the question together. Yay. So next we skip question 2 because question 2 is exactly the opposite of question 1. It's almost the same. As number 3, Sondos, do you want to read out the question?
Okay.
Or number 3?
Identify the types and functions of buffer system. Identify reagents that function as a buffer. So for me, the functions of buffer, it can resist the pH change upon the addition of an acidic or basic components, and it maintains the pH of solution stable, and it also prevents the radical change in fluid pH. And for the reagents that can function as buffer, you can use ammonia, pyridine, I don't know how to pronounce, pyridine, and acetic acid.
Okay, so just like I said before this, I'm just going to add on, like not so there's no repetition. It's okay to have repetition actually. There's 2 types of buffer, which is acidic buffer solution and basic buffer solution. If it's basic acidic buffer solution, it consists of weak acid and strong conjugate base of the weak acid. So same goes to basic buffer solution. It consists of strong base and it's consists of weak base and strong conjugate acid of the weak base. Yeah.
Okay. So Kelly?
So
I think I'll same with Audrey. Like buffer solution have 2 types: acidic buffer, which is it has a lower pH, like pH lower than 7, but the basic buffer solution is have a higher pH value, which is higher than 7 lah. So the example of the acidic buffer solution I can provide is CH3COONA. I forget the chemical names already. Like CH3COOH is a weak acid, while maybe sodium chloride is a strong base. Then when we combine it, it will become acid buffer solution. Am I right?
yeah, correct.
Yeah. So
But
uh,
is the CH3COONA sodium ethanol weak? No, I'm just double is it? Or am I wrong? Because I'm not sure also. Caca pandai je sini. Okay, it's okay.
I throw my chemi out already. So
Okay, it's
for
okay.
the basic buffer solution, like a strong strong basic and a weak conjugate base, weak conjugate acid. Strong alkali, weak conjugate base. So we can make it like maybe a strong acid NH4 ammonia. Ammonia is a
Ammonium.
strong ammonium. Thank you. Yeah, like ammonium and maybe a low concentration of hydrochloric acid, then we can form a basic buffer solution. That's the example. Yeah. Sorry. Okay.
So any add-ons?
I will add for the function, the buffer will remove most of the hydrogen ion if there is excessive hydrogen ion. So the pH will be maintained. So it will also remove the excessive hydroxide ion if the alkali were added. So the pH will be maintained. That's all.
Okay. So Hafi, do you want to read out question number 4?
Question number 4. Why the pH of freshly boiled deionized water slowly become more acidic when left exposed to the atmosphere?
So anyone can answer this, or should I start first, or you guys start first? Or you want to start first?
So I can start.
Okay.
So if the water, the boiled water left exposed to the atmosphere, the air contains CO2, right? That we dispose. So the CO2 will dissolve in water, and the carbonic acid will be produced. So that's a chemical reaction between the water and the CO2. So the carbonic acid produced, so hydrogen ion will more produced, so the pH will be decreased because there is hydrogen ion.
Okay, so now I'm going to explain why boiling water has higher pH compared to cooled water. It's because when we boil the water, high temperature can actually kill bacteria, because bacteria it causes acid, and when it's boiled, bacteria can be killed, and hence it make the water become more basic. So this can show that why boiled water is more basic than cooled water, and when it is left cool, just like what Hafiz say, yeah, carbon dioxide from the air surrounding will diffuse into the water and hence make the water more acidic. So the pH will drop.
Okay, I think I'm agree with Audrey and Hafif. So for me, the boiling water will have a higher pH value compared to the cold water is because like the boiling water is at high temperature. As we know, high temperature, the protein, everything. Why the protein? No, the high temperature is not a good surrounding for bacteria of that. So maybe bacteria will not live in the boiling water. Yeah, so the pH value will be higher than the cold water. But for me, the cold water is because when the deionized water is cold, when it exposed to the surrounding, it will how to say it will expose to like water. So the water have hydrogen ion and hydroxide ion. They will absorb the hydrogen ion and hydroxide ion in the water. Then they will form carbonic acid. Then when they form carbonic acid, it become an acid, so it will reduce the pH. Understand? It's a bit blur. Yeah.
So
How
yeah,
about some else?
just like you guys said, the cold water will come in contact with the atmosphere, so basically with CO2, and when water and CO2 react, they will produce carbonic acid. And carbonic acid has low pH, so it will lower the pH of the water. So that's why the cold water has a lower pH than boiling water. Yeah.
Okay, so that's all for our part 1. I didn't miss out anything, right?
Yeah, no.
Okay, so let's proceed with part 2. Part 2, there's only 2 questions. And let's combine those 2 questions in just one go. So the question is, what is the fundamental theory that represent sourness and acids? And the second question, what is the fundamental theory that represent bitterness and alkali? So anyone?
Basically, so who wants to start?
You start first.
Okay.
Yeah.
Sour things are mostly related to acids, and bitter things are alkali.
Okay.
Okay, so I think I go next.
Yeah, just add-ons. Yeah.
So the theory I found is Arrhenius theory and Bronsted-Lowry theory. That's the 2 theory I found. Yeah, so maybe Aubrey, you found the Bronsted-Lowry theory also, right?
Yeah.
Maybe I explain one, then you explain one.
It's okay. You just explain. Later can add on.
It's too long. Okay, so for the Arrhenius theory, for the acid part, it states that any substance that dissociates in water to produce hydrogen ion or hydronium ion is acid. So means when any substance, when it combines with water, which it will dissociate become hydrogen ion or H3O plus, which we call as hydronium ion, it is acid in Arrhenius theory. While in the other way, the base is any substance that dissociate in water to produce hydroxide. So it's like when something combined with water, it will dissociate, become hydroxide ion. So we can call it as base. Okay. So for the Bronsted-Lowry theory, I give.
No, it's okay. Continue.
Audrey. It's too long. Okay, you say lah.
Or Hafi goes first.
For me, I found that different receptors are triggered by different chemical compound or molecule present in the food. So the sour taste receptors are triggered by acid, or more specifically by hydrogen ion. So therefore, the tongue will detect, the receptor in the tongue will detect the presence of hydrogen ion. So the hydrogen ion is pH low pH. So yes. So
So
sour.
actually, from me, I didn't do the bronze something theory. Yeah. I didn't do that one. But because for like in this question, from my understanding of this question, I didn't go relate with the 3 theory. I didn't think of that. Because my understanding to this question is like, so like sourness and acids means they have lower pH, means that they have higher hydrogen ion, means if it is a stronger acid, it dissociates completely in water, and if it's a weak acid, it dissociates partially in water. Yeah, because this is my understanding towards this question, so maybe I misunderstood this question for this question, so maybe it's good to have a discussion so that I clear this misunderstanding. Yeah.
I think I add on some Bronsted-Lowry theory lah.
Yeah.
Okay, so for Bronsted-Lowry theory, what I found is acid is any substance that can donate a proton, which it can donate a hydrogen ion from itself. while base is any substance that can accept a proton. So the differences between these two theories, like one is mentioned about they donate a proton, one is mentioning about when it dissociates with water, it will produce hydrogen ion or hydroxide ion. So yeah, that's the fun fact about these two theories. That's what I found.
Okay. So for part 2, I guess we all, because I misunderstood the question, so I'm very sorry. Yeah. So it's okay. It's good thing for us to have a discussion. So everyone clear with part 2? Should we continue with part 3?
Yes.
Okay. So the part 3 is basically just what we can conclude from the part 1 and part 2. So for number 1, it's about discuss our limitation of the pH measurement and how does this affect the accuracy of the measured pH value. So just like our part 1 experiment that we did, I'm sure that some of us don't get the exact pH value. Yeah. For example, like actually mine also not that accurate because I'm just taking the most nearest color to the pH indicator. So that's one of the limitations because pH indicator can't detect the exact pH of the pH value. And any add-ons for the limitations?
Yeah, like for me, for the for the multimeter, I got a negative value for the first time, and then I got positive value, so it's not accurate, and it's not stable reading.
Then I think for me is because I use a soy sauce, it's a stain solution, so maybe it can't produce a clear result. pH paper only will show a better result in a colorless solution, so I think that's a limitation of pH paper. Besides, I feel that the pH paper does not so accurate because try to imagine like when we take the pH paper out, it will contaminate with the air, so it will like the theory just now absorb with carbon dioxide or hydrogen, so it might affect the pH value of the solution. That's what I thought lah.
For me, the limitation is difficult to match the color of the strip with any of the color shown in the indicator. So sometimes the color was not clear and the color was apa or pudar or what
It fades.
yes. So
Yeah.
also there's a temperature compensation. It may affect atmosphere, so maybe high temperature will affect the solution that we measured the pH of. So that's it.
So I have another limitation actually, but yeah, I know that the multimeter actually shows a more definite reading, but the problem here was that some of us might not get a stable reading for it. Even though we wait for a long time, there's still no stable reading for it. for it. So that's actually a part of the limitation also. So let's continue with our number 2. Like what improvement we can make on the pH sensor based on the limitations. Oh, okay.
We can take many readings, and then as we did, we can take the average, so that because it's not very fixed. So this is one improvement that we made.
Yeah, agree. Okay, so
yeah.
So for me, I think that maybe maybe afterwards we can invent something to replace the universal indicator, like the old one. Like we try to change the material of it, let it can detect the other solution that stain one, like not just only test about colorless solution, because we have so many solutions that can be tested if we change the material of the paper. Yeah. So, or maybe we can count if with a more detailed pH list, like the list. One of the problems during an experiment is I can't really sure that the pH reading of the result that I get. So maybe I come with a more detailed pH list. Yeah, I think that's for me lah.
For me, it's the same as Sondos. We can take many readings, so we need to prepare more pH strips so that there's no mistakes we done. Also, we need to do in the room temperature, so there's no other external effect that can change the pH. Yes.
Agree.
Okay, so mine was just basically same as Sondos. So I have nothing to add on. Cause why do we need to get the average value of the readings? It's because it increases the accuracy. Yeah.
Yes.
Yeah. So then we have lesser. I'm not saying that it's a mistake, but then I'm saying that it's more accurate if we take the average value. Yeah. So number 3, determine the difference between pH sensor via current value and the conventional methods. This should include the technical aspect of both methods. What do you guys know about this question? How do you guys understand this question?
I
We
think
have to. Okay.
Yes, Happy?
the value that we get, the result that we get. So there's difference between pH sensor with current. With current, we get the current value that is, I think that is more specific compared to the conventional method where we use the pH. So the result are more general and not specific. Yes, I think.
Yeah.
For me, the differences between the okay, we assume the pH sensor via current value is multimeter. The conventional method is the pH paper. So for me, the differences between pH meter and pH paper is pH meter is more accurate as it can show 2 decimal place. Yeah, but pH paper we can only know is pH 8 or pH 9. Besides, I feel maybe pH, but multimeter is better than pH paper because we can't say how to say because we can adjust the pH meter, right? We can adjust the voltage, the current, the resistance. So maybe it can give a more variety compared to pH paper. Am I right?
Yeah.
Maybe.
It's because I agree with Kelly saying that pH meter is better than pH indicator. It's because pH indicator, the range of it was too wide.
Yes.
Like, I mean by what does I mean by range was too wide? Like, it only shows 1, 2, 3, 4. It doesn't show like 1.12 or like 1 point. Unlike multimeter it shows 2 decimal point, which give us a more accurate reading. Yeah.
Yes.
So I guess that
Can I add on? I think maybe pH paper can give a more direct pH, unlike multimeter. If multimeter, we only can observe the current, the resistance. We can't actually know the pH value unless we go to calculate it and understand the concept. So maybe pH paper is more direct. Yeah, maybe lah.
Yes. Yeah. pH meter doesn't shows the pH value. Yes.
Yes.
Yeah, I'm
Yes,
not.
the
Yeah,
Q
I'm aware of it. Okay. So any add-ons? If there's no add-ons, we should explain our part 2 experiment that we conduct because we all use resistance. So maybe we should state how does it relate to current.
Okay. You can do that.
Hydrogen ion was actually the current flow. So we are using the resistance, like we are all following the video except Hafi. I think Hafi did the right one because Hafi did current, direct current, so it's actually not wrong. It's actually quite direct. So the three of us use resistance. So I think we should explain about how does resistance relates with current. So should I start first or do you guys want to start first? Oh, okay. So from my understanding, since metrics or secondary school, um, resistance is inversely proportional to current, which means if the current is high, the resistance will be low. It is opposite. So as we can see from our results, if it's supposed to have lower resistance because acids have high amount of hydrogen ion, which means have high current, which cause low resistance. Do you guys get me?
Mm.
Okay, so any add-ons?
For me, I'm not sure about the resistance part because I got all are almost acidic, but then I got random values, like I got a negative value. So I can say that using current is better than using resistance because current is directly proportional to the solution, or the acidic solution.
Okay, so for me, I think I'm agree with Sandos and Audrey. So like we learned before the Ohm's law, V equal to IR. So like current is directly inversely proportional. Yeah. So when the resistance is low, the current will be higher, like inversely proportional. So when the current is higher, means that in the circuit there's a lot of dissociation occurs, which is in this experiment we are test for dissociation for hydrogen ion lah. So when we realize the current higher means the dissociation of hydrogen ion is higher. So definitely the pH will be lower because we know from the pH formula is negative log hydrogen ion concentration, right? So when we have a high hydrogen ion, then we have a low pH. Yeah, that's for me.
Okay. So
Okay.
I think this have already answered the question of the relationship between resistance and current, as this doesn't affect our 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 result and discussion because current is directly like just current and resistance is actually connected with current, so we can relate to it and do this as our discussion. So I think that is all for our discussion. Any add-ons, like any questions to add on? If no,
I think no.
okay. So if no, thank you for listening or not listening. Thank you for discussing and join today discussion. So I think this is all for our discussion today. If there's no questions or problems, I think we can end this video. And if doctor is listening, thank you, doctor. Okay, so we can actually stop this recording already.
Yes.